So hello everyone, welcome to another particular stereochemistry lecture, and this is the lecture 7 of our stereochemistry course. And in this particular lecture we are talking about the naming of chiral compound, like how can we name the particular chiral center, or we can say that how can we name the absolute configuration or determine the absolute configuration of the particular chiral compound. Okay, so this lecture will be a little bit huge because many things we have to learn in this particular lecture, and I would highly suggest that please pay attention in this particular lecture because it is little bit of confusing, but hopefully I will teach you very minute way. Okay, so start with our particular lecture. So basically, naming of chiral compound, like chiral compound, various scientists have been given different of nomenclature formula, such as RS nomenclature, that is given by Crane, Inlog and Prelogs. Okay, so this is the widely used nomenclature. Also DL nomenclature was there, that is given by Fischer. Trio electron nomenclature, EZ nomenclature. These are the mainly four important classification of how we can determine the chiral compound, or we can name the chiral compounds. Okay, so initially we begin with our discussion with the DL nomenclature. So DL nomenclature is mostly used for carbohydrate chemistry or sugar chemistry and amino acid chemistry. It is introduced by Fischer. Okay, so the DL nomenclature contains certain rules. Like initial rule is that carbon center that contain a maximum number of carbon atom or functional group contains the most oxidized carbon is taken as a root chain. This is a very important, like in the vertical chain that can be determined as a root chain here. Okay, and the vertical chain, the representation is something like that. The most oxidized carbon, that is here, you can see here that the COOH, the carbon is the most oxidized one, so it will present in the top in the root chain. Okay, now root chain is written in the vertical fashion that I have already discussed, that the vertical line is contains the root chain, and the Fischer projection formula of the maximum written on the top atom. According to the IUPAC system, that's not that important. Now, if the carbon chain is often the type of RCR, like if the both are the alkyl group, okay, then the smaller alkyl group is written in the top. So it is very important, you have to check on that. And the third rule is, if the chiral center contain one hydrogen atom and another group containing heteroatom, or we can say the electronegative atom, among the four ligand, then the group containing heteroatom is placed on the right is called D, and if it is placed on the left is called L. That means if we take the example of this particular molecule, so here the representation is such as like the highest oxidizing group should be on the top. Okay, and the vertical chain is considered as a root chain where the longest alkene chain was there. Now in horizontal bond, now if we place our compound such a way like this, and if you find that the heteroatom or the most electronegative atom present in the right hand side, then the nomenclature is the D. So this is a lactic acid and it is a D-lactic acid. Similarly, in this particular example, so the root chain is determined here. Now the most electronegative group present in the left hand side, so it is called a L-lactic acid. Okay, I hope it will be clear till now. Now there is a certain rule is there, like when two ligands attach to a chiral center, one is an alkyl group and the other one is an electronegative group that I am discussing there. Okay, like this is the alkyl group and this is the highly electronegative group. So we are talking in terms of the electronegative group position, we can determine the D and L nomenclature for the same. Okay, so here in this particular example, the OH group present in the left hand side, right hand side of the molecule, so this way the D. And similarly here both of these two, the CH3 and the amine NH2 group, the NH2 group is the mostly electronegative group, so this will determine the naming. So this is the L. Now in certain case you find that when the four ligand attach the chiral center, two of them are electronegative atom and two of them are alkyl group. Then alkyl group are taken into the root chain that I am already discussed in the rule number 1, that the RCR type of thing will be the root chain, and the configuration of the molecule is determined for the respective position of the electronegative group of atom. Like example, in this particular compound, we can see that the alkane group present in the root chain, and here bromine and chlorine both are the electronegative atom. So the naming will be containing these two group as well. So that means the naming of the particular compound is L-bromo, that is the bromine present in the left hand side, so it is called the L-bromo, and in terms of chlorine present in the right hand side, so it will be called D-chloro, and rest the molecule name is there. So with this particular rule we can assign any molecule as either it is a D or L nomenclature. Now we are looking for the RS nomenclature. That is a very important in terms of exam point of view as well, and in terms of normal stereochemistry point of view. This then the absolute configuration, that is the R and S, are very important. Okay, so now we are talking about the RS nomenclature. RS nomenclature is introduced by Cram, Ingold and Prelog. That is, it is called the CIP rules. Okay, and now here the R stands for rectus and S stands for sinister. It is completely depend upon that how the molecule is rotates. Okay, now rectus means it is a clockwise rotation and sinister means the anti-clockwise rotation. Okay, now before entering the RS nomenclature, there is a certain things that called priority rule or CIP rule of atom. We have to deep down on this particular rule, that is the CIP rule. Okay, now CIP rule suggests that here in this particular group they are assigning this particular group as a priority, like between this four group, which group will be the highest priority, and then the second highest priority, third highest priority, and depending on the priority we are looking for a rotation, like the clockwise rotation is there or anti-clockwise rotation is there, and from there actually we are determining the absolute configuration of the chiral carbon here. Okay, so the determination of priority contains certain rules, that is called as CIP rules. So we are not dealing about with the CIP rules as well. Okay, so what the first rule suggests? First rule suggests that a priority group on an atom is first decided by the mass number. For example, here in this particular molecule you can find that the bromine has the highest mass number, so it will be the priority 1. Similarly, chlorine contains the second highest mass number between these four particular group, so it will contain the second number, and followed by methyl, it contains the third, and this hydrogen having the least mass among these four different group, so it will be a fourth priority group. So it is a priority order is written here. Okay, and also another important thing is there, like heavier isotopes get more priority than normal isotopes. Like if it is a hydrogen is there, and if it is present and not the methyl, if here the deuterium present here or deuterium present here, so deuterium having the highest mass than hydrogen, so it will be 3 and it will be the fourth priority group in this particular system. Okay, now there are certain rules are there. So the second rule is, if the same atoms are attached directly to the chiral center, then beta atom are taken into consideration in order to determine the priority sequence. If beta atom fails, then gamma atom are chosen, if some case delta and further group are taken. So it will be a vague statement. We just analyze this with a simple thing. Okay, so here these two can the priority of these two can be determined easily, but the confusion arises between this particular two group. Now here in this particular group we can see that here this carbon contains one hydrogen, two hydrogen and one carbon. Okay, this is the cell of this particular molecule. Now here you can see this particular carbon also the same, like two hydrogen and one carbon bind. So this is the alpha center. We can't determine this particular group that whether these are the same priority or not. So we are looking about the adjacent carbon or beta carbon here. So here beta carbon, you can find that it contains two hydrogen and one oxygen. Here it will be a two hydrogen but one carbon. So between if we consider about the priority order between this center and this center, both are hydrogen is there, but here the carbon is directly attached to the oxygen, and here carbon is directly attached to the carbon. Now in between carbon and oxygen have the highest mass number. That is the rule number 1. So that means that this group will get higher priority over this group. So this will be priority 1, and eventually this will be priority 2, this will be priority 3, and this will be priority 4. Now another important thing is, when we are talking about the mass, it doesn't necessarily all the time that we are looking for the mass of the whole group. This is completely wrong. We are only looking about the which bonds are connected and about their mass. So it will be a next rule. We can actually understand that what I am saying here just now. Okay, so here you can see that the clause 2a contains that between the two groups CH2SH and CF3 carbon, the first atom is both the cases is carbon. So we can't determine the priority by seeing the carbon itself. Then we move to the second atom, but regarding the second atom, the CH2 is containing S and CF3 group contains 3F. Now hence S has a higher atomic number, priority of the CH3 group is more than CF3 group. Like here example, see this particular carbon center is contain 3 fluorine, and this particular carbon center is connected with 2 hydrogen and 1 sulfur. Now ideally speaking, that this particular group have higher mass than this particular group, but the rule suggests that if the carbon or this particular center is connected to a group, that particular group had higher mass number than any of this particular group with the competing carbons containing groups. Okay, like here in this particular 2 carbon center, this particular carbon center is connected to a sulfur that is a higher mass than fluorine. So the rule suggests that irrespective of this particular overall group mass is much higher, but still that particular carbon is connected to a group that have that particular individual group have higher mass than any of the substituent present in this particular group, then it will be a highest priority. So please remember this particular thing. It might be confusing sometime, but when we are doing question answer, you have to be very cautious that about the priority order. Like most of the time, the student, including me itself also, I have done some terrible mistakes by giving the highest priority of this particular thing because of that particular clause, that the highest mass number will be the higher priority. But it is not always true. Like if not the overall mass of the group is not considered, mass of the individual substituent was considered here. Okay, now let us talking about the second clause of this particular rule. So it has been taken that between CH2CH2Cl and CCH3, the priority of CCH3 whole 3 is greater than CH2CH2Cl. Okay, so in this particular group, okay, so we are checking about the priority of this particular 2 groups. So here the carbon that contain 2 hydrogen and 1 carbon. Okay, but here this particular group contain 2 not only 2, there is a 3 carbon. So we are actually going periodically going first. Okay, although this particular carbon contains a Cl, that is the highest priority group, but we have to go periodically. Like initially first, if we check about this particular group, if this alpha carbon is failed to determine the priority order, then we go for beta carbon. But here it will be clearly observed that here the carbon contains 2 hydrogen and a carbon. Okay, but here it is a 3 carbon was containing. So that means this particular group priority is much higher than this particular group. So that is, it is written here. So I would suggest that read the statement very carefully and tally with the given example so that you will understand properly. Okay, now there will be another clause is there here, like to determine the priority of a branch in a molecule, the senior-most chain is taken into consideration. This is a very important thing. And if the senior machine or senior chain itself cannot decide, the second senior-most chain is taken into consideration. Okay, so we just example here, like see here in this particular case, if we go via this pathway, okay, this particular carbon is symmetrical for all the cases, like here also two carbon and one hydrogen is there. Okay, and similar case was observed here also. Now we can say that these two are somewhat identical, so it can't give the exact priority determination of the particular compound. Now from which way we should go to the highest chain, the branch molecule. Okay, so ideally speaking, if you want to check that if we go via in this particular group, if we go via this pathway, so after 1 and 2 in the second carbon itself we found the OH group, that is the highest priority group here. But are this carbon has the highest priority than this? The answer is no. Why? Because here in this particular carbon center there will be 2 carbon and 1 hydrogen, that is a C, and here is the H. But here in this particular carbon center, all are the carbon. So between these two group, the priority of this particular carbon is higher. So we have to choose this pathway, not this pathway, because here written that senior most chain is taken into consideration. So this senior most chain is something like this, because this particular center or this particular carbon is the highest priority over this carbon. So our pathway is something like this. Now if we go the pathway something like this, so it will be 1, 2, 3, 4. So here if we go via this pathway, in the 4th carbon we got the OH group here. Similarly here between this and this carbon center, this will be the highest priority because over this. So our way of consideration chain is this. So here it will be 1, 2, 3. So here in the third carbon itself we got the OH group. So that means this particular group have more priority. And see, now another thing you have to take very carefully here, you have to check very carefully, like here between these two carbon, the second carbon onwards. Now here interesting thing is that this particular carbon priority is much higher than second carbon. Okay, so you may be asked that why we are not going via this pathway, although in the both pathway we got the OH in the third, I understand, but since I am already repeatedly telling you that we are talking about periodic, we are going via periodical pathway. So since this particular group or the carbon number 1 is getting more priority than here, then we should stick to this particular chain only, not this particular chain, even if this particular group contain the highest priority over this particular group. If this particular group is present here, okay, here also a CH3 is there. Okay, so then these two are the similar priority order, so then we go via this pathway. But since this particular Me is not here for this particular molecule, so we should have to go this pathway. So it will be little bit of confusing, but as you gradually do the questions, then you will be very much clear about this. Okay, Now another very confusing thing, but still it will be understandable if you are doing questions. So another part that will be little bit of confusing, but if you are doing that, you can if you are understand this particular property, then it will be very easy. Like double bond and triple bond. If your molecule contains double bond and triple bond, then it will be a new concept was introduced, that is the phantom atoms. Like this particular carbons, okay, this double bond can be broke apart this particular group, and this the blue colors carbon and the blue colored bonds are called phantom bonds. Okay, so phantom bond signifies that this C are actually connected with another carbon center, that is this. So it can be a representation technique. And similarly, this particular carbon is also connect with this. So here is a phantom atom. The concept of phantom atom is introduced, and the concept of phantom atom is introduced to determine the priority of the particular molecule. Okay, so here it is clearly written that double bond and triple bond are considered as 2 bonds and 3 bonds separately. The atom connected by double bond or triple bond are considered to be joined of those bonds separately, and rest bond of the tetravalency are emerging through phantom atoms. Like here, if there is a triple bond is there, so there will be a, that means this carbon can be joined, we can say that the carbon can be joined like two different C center, because this particular 2 carbon center is nothing but this, but written is a phantom way. So we can determine the tetravalency of the particular compound and determine the priority. So always remember that the triple bond has the highest priority over the double bonds, because here in triple bond you can find that there will be 3 particular carbon center is joined with this particular carbon, that is a point of interest now. And here there's a 2 carbon and 1 hydrogen is there, so the priority of this particular triple bond is much higher than the double bonds. Okay, and configurational priority, like if it is both are in the double form, then obviously cis conformer getting the highest priority over trans conformer. R conformers, if the meso compound that will be discussed later, then R conformer is much more getting priority than S, and similarly RR or SS will over greater priority than RS. So with this we are actually end with our CIP rule to determine priority. Now we are talking about that how to assign the chiral absolute configuration of the chiral center, that is this. Okay, but before that we are actually tabulated the general priority of the, so you can go through it and you can get a very overview of the particular priority orders. Okay, now let us talking about the RS nomenclature. Now how can we determine the absolute configuration of our particular chiral centers? Okay, so after assigning the appropriate priority, the 4th priority group actually very crucial to determine the RS nomenclature. Okay, if the 4th priority group is in a vertical bond of a Fischer projection, that is very important line, that if the 4th group is present in the vertical bond of the Fischer projection, then you have to check the sequence or the rotation sequence from highest priority to the second to third. If the order 1, 2, 3 it is clockwise, then the configuration is R. But when your 4th priority is in the vertical bond, this is a very important. If the 4th priority is a vertical and the order of rotation 1, 2, 3 is clockwise, then the configuration is R. That is a rectus, that is means right. That is called as mnemonic rule. Okay, and similarly if the 1, 2, 3 priority order is anti-clockwise in nature, then the configuration is S. So we are actually dealing with a simple example here. So in this particular group, the bromine have the highest mass over this particular 4 different groups, so it will be the highest priority. Now here between CH3 and phenyl group, this particular carbon contains 2 different carbon and 1 hydrogen. no, sorry, it is a two different, actually it is a three different carbon actually are connected, because one is the double bond, so we can say that it is the if we apply the phantom carbon here, so this particular carbon center is connected with three different carbon centers, so it will be the second priority as it is depicted here, and obviously methyl got third and the hydrogen got fourth priority. And now in this particular group you can see that the particular fourth priority group is in the vertical bond. Now since it is a vertical bond, and now we have to take in the consideration of the rotation 1 2 3. Now you go there, 1 2 3 is a clockwise rotation. So first we are talking about the priority order. Priority order is pretty much clear now. Then we are talking about the rotation. Then fourth group, vertical bond, check. So as per the mnemonic rule, we can say that the particular configuration of this particular chiral center, that is R. Now what if their fourth priority group is present in the horizontal bond? Okay, now if the fourth priority group is in the horizontal bond, if the fourth priority group is the horizontal bond of Fischer projection, then you have to, the complete mnemonic rule is reversed. Like when the fourth priority group is horizontal bond and the order is 1 2 3 is clockwise, instead of R, now the configuration is S. And if the 1 2 3 is counterclockwise or anti-clockwise, then instead of S the configuration is R. So we just go through a simple example right away. So here the same example, but the particular hydrogen or the fourth priority group present in the horizontal bond. Now we have to check the particular rotation 1 2 3. Now it is also become a clockwise rotation. Okay, but since the fourth priority group present in the horizontal bond, then R is not here. Then as per this particular rule, clockwise, but fourth priority group is the horizontal bond, then configuration is S. I hope it will be clear for you. So since there is a very much naming rules, there is a are still left. So actually I have divided the particular lecture to different half. So in the first part of our naming of chiral compound, we have discussed about the DL nomenclature, and we are talking about the priority rules or the CIP rules, and then we are talking about the how to determine RS configuration of a Fischer projection formula. So with this we have to end this particular lecture. In the next lecture we are talking about some kind of interesting concept, like if your compound is a flying wedge projection, how can we determine the RS configuration? And then we are talking about the trio erythroisomers, EZ nomenclature, as well as the prep-prop configuration. So with this we have to end this particular class. So thank you for listening.